Conic sections. Conic sections are the curves obtained when a plane cuts the cone. A cone generally has two identical conical shapes known as lips. We can get various shapes depending upon the angle of the cut between the plane and the cone in its lip. By cutting a cone by a plane at different angles, we get the following shapes: circle, ellipse, parabola, and hyperbola. What is a parabola? A parabola refers to an equation of a curve, such that each point of the curve is equidistant from a fixed point and the fixed line. The fixed point is called the focus of the parabola, and the fixed line is called the directrix of the parabola. Also, an important point to note is that the fixed point does not lie on the fixed line. The key parts of a parabola are the vertex, axis of symmetry, focus, directrix, and latus rectum.
The general equation of a parabola is y is equals to ax minus h squared, or x is equals to ay minus k squared, wherein h and k denotes the vertex.
The standard equation of parabola is y squared equals 4ax.
So, let's quickly understand the parabola equation of y squared is equals to 12x, with its vertex at the origin. Our equation is y squared is equals to 12x. The standard form of a parabola opening left or right with vertex as its origin is y squared is equals to 4ax. Comparing them, 4a is equals to 12. Solving for a is equals to 3. Since a is positive and y is squared, this parabola opens to the right. So when plotting for the parabola, our coordinates for vertex is 0 and 0. For focus, it is a and 0, which is 3 and 0. For directrix, it's x is equals to negative a, or x is equals to negative 3. For axis of symmetry, y is equals to 0. For LR1, a and 2a, or 3 and 6. For LR2, it's a and negative 2a, or equals to 3 and negative 6. And for the length of the latus rectum, which is 4a, or 4 times 3 is equals to 12 units. Now, let's quickly analyze the parabola equation y squared is equals to negative 1/2 x, with its vertex at the origin. Our equation is y squared is equals to negative 1/2 x. The standard form for a parabola opening left or right with vertex at its origin is y squared is equals to negative 4ax. Comparing them, negative 4a is equals to negative 1/2. Solving for a is equals to negative 1/2 divided by negative 4, which is 1/8. Since a is positive, but the coefficient of x is negative, this parabola opens to the left. And for plotting the parabola, the coordinates for vertex is 0 and 0. For focus is negative a and 0, which is negative 1/8 and 0. For directrix, x is equals to a, which is x is equals to 1/8. For axis of symmetry, y is equals to 0. For LR1, negative a and 2a, which is negative 1/8 and 1/4. For LR2, negative a and negative 2a, which is equals to negative 1/8 and negative 1/4. For the length of the latus rectum, which is 4a, or 4 times 1/8, which is 1/2 units.
This time, the parabola opens upward. We're given x squared is equals to 4y. This fits the standard form of a parabola x squared is equals to 4ay. Because the value is positive, the parabola opens upward. Now, solving for a. From the equation 4a is equals to 4, divide both sides by 4, we get a equals to 1. Then we compute 2a is equals to 2. We'll use this when finding the endpoints of the latus rectum. Now, let's identify all important points and lines. Vertex at the origin, 0, 0. Focus, 0a. Replace a with 1. We get 0, 1. Directrix, y is equals to negative a. Replace a with 1. Y is equals to negative 1. Axis of symmetry, x is equals to 0. The latus rectum is a horizontal line segment that passes through the focus. Endpoints of the latus rectum 1, 2a, a. Replace a with 1, we get 2 and 1. Then, latus rectum 2, negative 2a and a. Again, replace the a with 1, we get negative 2 and 1. The length of the latus rectum is 4a is equals to 4 units. Let's review the graph. The red curve is the parabola, the blue point is the focus, the yellow line is the directrix, points negative 2, 1, and 2, 1 mark the ends of the latus rectum. And that's how you graph a parabola that opens upward using its standard form. X squared is equals to negative 8y. This equation matches the form x squared is equals to negative 4ay, which tells us the parabola opens downward. Solving for a. We compare negative a, 8 with negative 4a. Negative 4a is equals to negative 8. Divide both sides by negative 4. We get a is equals to 2. Now, we calculate 2a is equals to 4. This will be useful for plotting the latus rectum. Let's identify the parts of the parabola. Vertex is at the origin, 0, 0. Focus is 0, negative a. Since we solved for a earlier, replace the a with 2. We get 0, negative 2. Directrix is the line, y is equals to a. Since we got a is equals to 2, replace the a, y is equals to 2. Axis of symmetry, x is equals to 0. The vertical line passing through the vertex. The latus rectum is a line segment through the focus, perpendicular to the axis of symmetry. Endpoints of the latus rectum. Latus rectum 1, 2a, negative a. Replace the a with 2. We get 4, negative 2. Latus rectum 2, negative 2a, negative a. Again, replace the a with 2. We get negative 4 and negative 2. The length of the latus rectum is 4a is equals to 8 units.
So, let's now move on to this equation. Y minus 3 squared is equals to negative 12 times x plus 4, where the vertex is not at the origin. Our equation is y minus 3 squared is equals to negative 12 times x plus 4. The standard form for a parabola opening left or right with vertex at h and k is y minus k squared equals to positive and negative 4a times x minus h. Comparing, we see h is equals to negative 4 and k is equals to 3. So the vertex hk is negative 4 and 3. Also, negative 4a is equals to negative 12. Solving for a gives us 3. Since the coefficient of x plus 4 is negative, this parabola opens to the left. For plotting the parabola, our coordinates for vertex is negative 4 and 3. For focus, h minus a and k, which is negative 7 and 3. For directrix, x is equals to h plus a, which is x is equals to negative 1. For axis of symmetry, y is equals to 3. For latus rectum, negative 7 and 3, positive and negative 6. LR1 is equals to negative 7 and 9. For LR2, negative 7 and negative 3. For the length of the latus rectum, which is 4a, or 4 times 3 is equals to 12 units. Now, let's quickly analyze another parabola equation. y minus 1 squared is equals to 8 times x minus 4, where the vertex is not at the origin. Our equation is y minus 1 squared is equals to 8 times x minus 4. The standard form for a parabola opening left or right with vertex at h and x is y minus k squared is equals to positive and negative 4a times x minus h. Comparing, we see h is equals to 4 and k is equals to 1, so the vertex h and k is 4 and 1. Also, 4a is equals to 8. Solving for a gives us a is equals to 2. Since the coefficient of x minus 4 is positive, this parabola opens to the right. Now, for plotting the parabola, our coordinates for vertex is 4 and 1. For focus, h plus a and k, which is 6 and 1. For directrix, x is equals to h minus a, which is x is equals to 2. For axis of symmetry, y is equals to 1. For latus rectum, 6 and 1, positive and negative 4. For LR1, 6 and 5. For LR2, 6 and negative 3. For the length of the latus rectum, which is 4a, or 4 times 2 is equals to 8 units.
Now, we're learning how to interpret the equation of a parabola with its vertex at hk. We're given x minus 1 squared is equals to 8y minus 4. This follows the form x minus h squared is equals to 4a y minus k. This means the parabola opens upward. Compare the equation. 4a is equals to 8. Divide both sides by 4. A is equals to 2. We also need 2a equal 4 when we find the latus rectum. We get the 4 because replace the a with 2 then multiply. Now let's break down the features. Vertex from HK 1 4. We get 1 4 because since our equation is negative 1, make it positive for our h, and for the negative 4, make it positive for the k. Focus h, k plus a, 1 and 6. Because our a is 2, 4 plus 2 equals to 6. Directrix, y is equals to k minus a. Y is equals to 2. So basically, our a is 2, then minus 8 from our k. And now, it positive for the k. Focus h, k plus a, 1 and 6. Because our a is 2, 4 plus 2 equals to 6. Directrix, y is equals to k minus a. Y is equals to 2. So basically, our a is 2, then minus 8 from our k. And our k is 4. Axis of symmetry. Vertical line through the vertex. X is equals to 1. The latus rectum is a horizontal line through the focus. The endpoints of the latus rectum are 1 plus 2a, 6. So we get 5 and 6. 1 minus 2a, 6. We get negative 3, 6. The length of the latus rectum is 4a equals 8 units. On the graph, the red curve is the parabola. The point labeled F is the focus at 1, 6. The yellow line is the directrix. The vertex V is at 1, 4. The latus rectum endpoints are 5, 6 and negative 3, 6. And that's how you analyze a parabola when the vertex isn't at the origin. Now, let's explore another parabola. This time, one that opens downward and has its vertex at a point other than the origin. We are given the equation x plus 1 squared is equals to negative 1 over 2 y minus 2. This fits the general form x minus h squared is equals to 4a y minus k. Because the right side is negative, the parabola opens downward. We compare the equation to the standard form. 4a is equals to negative 1 over 2. Now, solve for a. A is equals to negative 1 over 2 divided by 4 is equals to negative 1 over 8. Then calculate 2a used for latus rectum. 2a is equals to 2 times negative 1 over 8 is equals to negative 1 over 4. From the equation, the vertex hk is equals to negative 1, 2. So, our h just from positive to negative, and for our k from negative to positive. Our focus, h, k plus a is equals to negative 1, 15 over 8. Directrix, y is equals to k minus a equals 2 plus 1 over 8 is equals to 17 over 8. Axis of symmetry, vertical line through the vertex, x is equals to negative 1. Now, the latus rectum, which is horizontal through the focus. To find endpoints, latus rectum 1, h plus 2a, k plus a is equals to negative a plus 2 negative 1 over 8 15 over 8 is equals to negative 5 over 4 and 15 over 8. Latus rectum 2, h minus 2a, k plus a is equals to negative 1 minus 2 times negative 1 over 8 and 15 over 8 is equals to negative 3 over 4 and 15 over 8. So the endpoints are latus rectum 1, negative 5 over 4 and 15 over 8. Latus rectum 2, negative 3 over 4 and 15 over 8. The length of the latus rectum 4a is equals to 4 times 1 over 8 is equals to 1 over 2 units. Check the graph. Red curve, the parabola. Point F, the focus. Horizontal yellow line, the directrix. Point V, the vertex, negative 1 and 2. Latus rectum points, the ends of the latus rectum. To convert the given parabolic equation from standard form to general form, let's expand and simplify them. Given equation, x squared is equals to 8, y plus 7, 2, x minus 2 squared is equals to negative 12y. First equation, x squared is equals to 8, y plus 7. Now, expand the right hand sign. Now we get x squared is equals to 8y plus 56. Rearrange to standard general form, ax squared plus bxy plus cy squared plus dx plus ey plus f is equals to 0, and we get x squared minus 8y minus 56 is equals to 0. And for the second equation, x minus 2 squared equals to negative 12y. Let's expand the square. We get x squared minus 4x plus 4 is equals to negative 12y. Now, rearrange. X squared minus 4x plus 4 plus 12y is equals to 0. And rearrange x squared minus 4x plus 12y plus 4 is equals to 0. And our final general form equation is x squared minus 8y minus 56 is equals to 0. And for number 2, x squared minus 4x plus 12y plus 4 is equals to 0.
Now, let's transform the general form of a parabola equation into its standard form. We'll start with the first example, y squared plus 8x plus 32 is equals to 0. Our goal is to rewrite y squared plus 8x plus 32 is equals to 0 to match one of the standard forms. Notice the y term is squared, suggesting the form y minus k squared is equals to 4p times x minus h. First, we isolate the y squared term by moving the x term and the constant to the right side. Y squared is equals to negative 8x minus 32. Next, we factor out the coefficient of x, which is negative 8 from the terms on the right side. Y squared is equals to negative 8 times x plus 4. Now, our equation is in the standard form y minus k squared is equals to 4p times x minus h. By comparing, we can see y minus 0 squared corresponds to y squared. Then, x minus negative 4 corresponds to x plus 4, and 4p is equals to negative 8. From this, we can identify that the vertex h and k as negative 4 and 0. And that's how we transform general form y squared plus 8x plus 32 equals to 0 into the standard form y squared is equals to negative 8 times x plus 4 and identify the vertex. So, let's transform the given parabolic equation from standard form to general form. Let's expand and simplify them. Y squared is equals to negative 8 times x plus 4. To solve this, let's expand the right-hand side. So it's going to be y squared is equals to negative 8 times x, which is negative 8x, and negative 8 times 4 is equals to negative 32. Let's rearrange the standard general form ax squared plus bxy plus cy squared plus dx plus ey and plus f is equals to 0. So, the standard form is y squared plus 8x plus 32 is equals to 0.
And now, we're learning how to transform a parabola from general form to standard form. Let's look at example number 3 from our list. Our given is x squared minus 4x plus 12y plus 4 is equals to 0. Group x terms and move the rest to the other side. Take the x terms and constant to one side. We get x squared minus 4x is equals to negative 12y minus 4. Now, complete the square. To complete the square, take half of the x coefficient which is negative 4. Square it. Negative 4 over 2 squared is equals to 4. Now, add 4 to both sides. X squared minus 4x plus 4 is equals to negative 12y minus 4 plus 4. X minus 2 squared is equals to negative 12y. We write it in a standard form. This matches the standard form of a vertical parabola. X minus h squared is equals to 4p y minus k. So our equation is x minus 2 squared is equals to negative 12 y minus 0. And our vertex is, from the standard form, we can see the vertex is 2, 0.
That's the end of our lesson about parabola. Thanks for watching!